Albert Einstein had no doubt that human beings were stuck in time like flies in amber. Every moment had been planned out from the beginning. Every action that any person took was a result of preceding actions. You had no control over your life. All you could do was observe. Whenever you thought you were making decisions about your life, it was an illusion. Your life was determined before you were born. If Einstein were a Christian, he would have been a Calvinist, believing that all souls are chosen by God for salvation or damnation before they were born. Since he wasn't, he believed in another determinist's God, that of excommunicated Jewish philosopher Spinoza. Time was simply a dimension along which God placed events, all perfectly set in glass. According to Einstein, he was meant to make all his discoveries. He was meant to become famous. He was meant to help kick off the Manhattan Project that ended in Hiroshima and Nagasaki and started the Cold War. Einstein's ideas about time as a dimension remain with us. Science fiction books, movies and TV shows like Back to the Future, Star Trek, and Doctor Who invoke his theory when they present time travel as a journey from one place in time to another, as if we are traveling from one real place that exists to another real place that exists. But do two whens actually exist simultaneously, or is now the only time that exists? Einstein was notorious for being hard-headed about any physics that disagreed with his philosophy. His attacks on Niels Bohr's quantum mechanics and its predictions of random events being common in the universe was offensive to his beliefs in determinism. "God does not play dice," is the oft-paraphrased quote. An old and very weird interpretation of quantum physics is making a comeback and challenging Einstein even more than the original did. And if it is true, we might do away with the idea of the past and the future existing somewhere out there entirely, along with other ideas like the multiverse, parallel copies of me and you living different lives off in some unreachable realm. David Bohm described this theory in 1952. As everyone knows, quantum particles like electrons and photons do not have definite positions or velocities until observed. Quantum mechanics instead says they have a wave function. In the usual Niels Bohr interpretation of what is going on, the act of observation somehow collapses their wave function so that they appear as particles. We know this from experiments like the double slit, where we fire individual particles at a pair of slits and see how they act like waves when we let them strike a detector on the other side, but like particles when we try to catch them in the act of going through a particular slit. Both Einstein and Bohm took issue with that and said that there has to be some hidden information that is really holding the locations of the particles. They don't just appear randomly as Bohr insisted. Bohm set out to resolve the problem and came up with the weirdest, but in some ways satisfying interpretation of quantum mechanics. It is now called Bohmian mechanics. In Bohm's theory, a set of particles like electrons or atoms are described by a quantum wave function, as in Bohr's version. Then the theory deviates from standard quantum theory. All the positions of those particles have definite values, even when not observed, described by another function which he called Q, or the guiding function. The Q function is that hidden information that Einstein wanted. Bohmian mechanics was deterministic, a plus for Einstein, and it accounted for all predictions of quantum mechanics. It did away with wave function collapse, indefinite particle positions, and didn't need a multiverse to solve it. It did keep one thing Einstein really didn't like: non-locality. The key point in Bohmian mechanics as it stands today is that the motion of every particle is, through the guiding function, dependent on the motion of every other particle in the entire universe simultaneously. So even though the particles themselves are local, their interactions with other particles is completely non-local. They violate the speed of light restriction. When you combine Bohmian mechanics with Einstein's relativity, you get a fascinating combination. Relativistic quantum mechanics is called quantum field theory, which we use to describe what happens when we smash matter together in particle accelerators. In the usual way quantum field theory works, you have operators that describe particles being created and annihilated. Bohmian QFT, on the other hand, never does either. Instead, particles just jump from one location to another like magic. So the particle that you thought was just annihilated or created was actually teleported from one place to another in the guiding function. Bohmian mechanics and QFT also both presuppose that the entire universe of particles has a single present time. It gets away with this because it tells you that you cannot know what that present is. Only the guiding function knows, and we can't see that. The universe as a whole simply evolves from moment to moment. Notwithstanding Einstein's relativity, but doesn't allow us to see this present for ourselves, except in our exact location. All this gets into what time is. If you are like Einstein, then you believe in what is called a block universe. The universe is a big four-dimensional block of stuff happening. It doesn't matter if you think some of that stuff was random, it is all set in stone. Another name for people who believe this are eternalists. Some eternalists believe in the growing block universe where only the past is set in stone and the future is unknown. They are like half-eternalists. If you don't believe in a block universe of any kind, you are a presentist. Presentists believe that only the present moment exists. The past is destroyed and the future is unwritten. So if time is like a highway, determinist eternalists like Einstein believe that we are just passengers in a car traveling on that highway. We are watching the scenery. We may even have a steering wheel and pedals, but the car is really driving itself. If we want to travel back in time, we would have to get off the highway and backtrack somehow to an earlier point in time, but our actions would still all be predetermined, and so we could never change the past. There are eternalists who believe in free will as well, but it is hard to reconcile the future being set in stone with having a free will. Presentists believe that time is not like a highway. Instead, time is like driving a car in a simulator. The simulator stays put and only creates the illusion of motion through time. The past is purged from the simulator's memory while the future is calculated. Only the present exists. Way back before Einstein, Isaac Newton had his own ideas about time. For him, the universe was like a clock. Time ticked away and the mechanisms all drove one another to perfection. God, the eternal clockmaker, created the universe to run itself. Presentists could argue for centuries that the clockwork universe was a perfect representation of only the present moment existing. Einstein threw a monkey wrench into presentist beliefs when he came up with his theory of relativity. The problem with relativity is that you can't actually agree with another person on what the present moment is. For example, we can't agree that two events occur simultaneously if they are moving relative to one another. If that is true, then how can we say that only the present moment exists? In quantum physics, the rules of relativity don't always apply. Instead, particles can affect one another non-locally no matter what interpretation. While we can't send information faster than the speed of light, we can detect particles influencing each other at superluminal speeds. If that's true, then what does that say about simultaneity? Are particles influencing one another simultaneously? How can that be true if Einstein's theory says there's no such thing? In the multiverse interpretation of quantum physics, particles influence one another, being in different places in different universes. So in that theory, it's like we have lots and lots of copies of the same cars traveling on the highway in different lanes. Sometimes cars vanish and sometimes they just appear from nowhere. Sometimes a car will split into two motorcycles and then merge back together. They're all banging into one another until someone looks at them and the lanes split off and you have different highways. So highways are always split off, sometimes merging. The past and the future are just as real as the present, and so are all the other realities out there. In Bohmian mechanics, it is like our cars are traveling down the highway of time, but they act like part of one big car, the guiding function. If it's one big car, it might as well be one big simulator. We are cruising along in our simulator along with everyone else. We can't know exactly what's going on with the other people in the simulator, sort of like that Disney ride, Flight of the Avatar. Sometimes the simulation makes us disappear from one spot and reappear in another. There is no splitting off into different highways, no cars appearing from nothing. Instead, our lives grow and evolve within the guiding function that determines our reality, never leaving the present moment. Our universe is simply built that way, just so you can have some jargon to take home with you. The present is described as a 3D hypersurface within a foliation of space-time. A hypersurface is like a surface, but in more than 2 dimensions. A foliation is just a fancy word for a way of cutting or slicing a volume, a 4-dimensional volume in this case. For example, latitude is a foliation of the Earth. Bohmian mechanics is appealing because it doesn't need ideas like wavefunction collapse, multiverses, or even the past and future. It restores something of the Newtonian idea of an absolute time without violating the theory of relativity at the scale of the universe. It also doesn't rely on particles being created and destroyed like quantum field theory, which, for now, we can't distinguish between it and any of the other interpretations of quantum mechanics, but a quantum theory of gravity might make a difference. Thank you for joining us today. See you in the next video. Until then, stay curious.